production securely on Kubernetes demo, focusing on Tanzu application service paradigms. We're going to start by looking at this pipeline that shows an application that we're going to take from code change to production through a test cloud on a public cloud and a UAT cloud on another public cloud and a production cloud, all running Tanzu application service for VMs or for Kubernetes. And this is where we're running our testing deployment. And this is the app. For those of you who are familiar with Spring, the canonical Spring example, Spring Music, and it has a blue bar here. And the change we're going to take to production is changing that blue bar into a green bar. And we're going to watch it going from the pipeline across a dev environment, and then again in our testing environment and UAT environment. And then we're going to do something pretty interesting. The production cloud actually doesn't exist yet. So we are going to show, while the pipeline is running, we're going to create everything from scratch for our production cloud on-prem on vSphere, from the Kubernetes cluster to the Tanzu application service to the databases that we need across the operations, DevOps, and line of business developers, and then let the pipeline take us all the way to prod. So without further ado, first let's start by making this dramatic change to our app, where we are hitting the Git repo and changing from blue app to green app, and committing the changes from blue bar to green bar. And then in a few seconds, our pipeline, which is based on Concourse, but you can use any pipeline that you want, as long as it can listen to changes in Git and have different targets. The real magic here is actually the Tanzu application service that completely abstracts the underlying infrastructure and gives you just a CF push experience no matter what cloud you are running on. We're going to give it a few more seconds, and here it goes. It started the unit test, it detected the change, and it's going to start building our app and then deploying it to the first cloud. While it starts running, let's start building the production environment. Step one, creating the Kubernetes cluster. We can do that from Tanzu Mission Control in two ways. We can create a cluster directly from here, for example, or on AWS, give it a name, next, and we have a cluster. Or we can attach to a running cluster, like we already have here, that is running on vSphere, which is going to be our production cluster. And when we attach to a cluster, we can actually see all the namespaces that are already deployed here. And in this case, we're going to have a few of the system namespaces, and then a load balancer, and also Wavefront, or as it's called, Tanzu Observability, which is something we are going to use later on in the demo to monitor our cluster. Then we're going to switch to our command line and start by deploying the Tanzu application service. But before we do that, as an IT operator, that we're still here, we're going to make sure our cluster is up and running and everything is fine, as we did from, we can see all the things that are already installed for us. We can also see that we have a storage policy, which we're going to need in order to deploy persistent applications like Tanzu application service for Kubernetes, and that we have load balancer and everything is great. And now we can hand off this cluster to our DevOps team in a line of business, for example, to start deploying the application service. So here, now I'm a DevOps guy, and I get my own cluster, my dedicated cluster, and I can see that I have the nodes running here. I have 3 masters, and I have 1, 2, 3, 4, 7 workers, and I'm ready to deploy Taz. Deploying Taz is a simple command that generates a script using the K-app target application and deploys Taz for Kubernetes on our cluster. It's going to run. It takes a couple of minutes to run. We are going to accelerate this in our demo and then see that it's completed. Before we do that, I do want to show you something, that we go to our Tanzu observability dashboard, and we can actually watch the cluster itself and what's happening inside. So Tanzu observability allows you to do many cool stuff on both applications and infrastructure. In this case, we're going to look at the infrastructure and search for our cluster. And we're going to see here all the nodes and the pods that are being created. And we can watch exactly what's going on here, see nodes per clusters, and do a lot of stuff that are relevant to how the cluster is actually operating. And we're going back to our command line and see if the application is Tanzu application service is deployed. It's still running. We're going to give it a few more minutes. While we are waiting for one more replica to be available, let's see how our cluster is doing. And we can see that we've already completed our test cloud and our UAT cloud. So if we go here into our test cloud and click the URL, we're going to see that the bar is green. So we're quite happy with that. You can see that right now in the test environment, I don't have any database, so no services. If I go to my UAT environment and click on the URL, I'll see that it's a green bar, and this time we actually have a database called RockDB, which is something that we provisioned from our public cloud repository. And in our production environments, we're going to use a different database that you will see in a minute. So both of our testing cloud and UAT cloud have been changed successfully with no downtime, by the way. And now we're ready to push to production, but of course, we need to create production first in the spirit of the demo. So let's go and see how our Taz K8 is doing, and it's complete. That's awesome. So step one, we're going to define some orgs and spaces. Orgs and spaces are the way Cloud Foundry or the Tanzu application service is handling application tenancy. And for that, we will need the administrator password, so we can have permissions to do that. We're going to take that little script here and run it. And now we are actually creating a few spaces in orgs and users. So we're going to have a dev user and a production user that we're going to use both. And after that's created, we can actually see that we have several orgs, and we can target a specific organization by doing this. In this case, I called it my LOB organization. And within that organization, we can actually target a specific space. Let's call it sandbox. And now what we want to see is we need a database, right? We need, like you've seen, we need a database to handle our backend system of the application. And if I do marketplace, I see that I don't have any offerings. And that makes sense because we just created this application service on our Kubernetes cluster, and there is no marketplace. So let's fix that. We're actually going to install both MariaDB and MySQL instances on this cluster by using something that is called KSM. And while it's installing the chart, I want to show you where this is all coming from. So we are going to use for that another offering from Tanzu called the Tanzu Application Catalog. And specifically, we're going to search for a MySQL offering. This is a private catalog that was created for my organization based on my base images and my release profiles. And what's unique about the Tanzu Application Catalog is it's constantly running releases and builds from the base image all the way to the Helm chart to make sure that our offering is secure and have everything we need in that. And that's the offering we're going to use to install in our KSM. We're going to specifically take this chart. We'll do the same for our MariaDB Helm chart. We're going to install this one as well. Let's get back to our KSM, and we see that the basic scaffolding of the marketplace exists. And we're going to install the KSM offers, both MariaDB and MySQL. This would actually go into the CF marketplace, register the broker and the services, and enabling all the plans. And now if we do CF marketplace, you can actually see that we have both MariaDB and MySQL with the plans we defined using a simple YAML files in our install base with dev and prod. And we are ready to actually push an app. Log in as our production user, which is one of the users we created in that script before as a DevOps persona, and we are logging in. And you can see that we can only see one space in one org. And that's part of the multi-tenancy definition that we did, where the production user can only access the prod. It doesn't see other spaces. And in the same concept, the developers will not see the production organization. And if we're doing the CF marketplace, we should be able to see the available services that we registered in the previous phase. And here is our MariaDB. So let's create one so our pipeline can actually deploy the application into our newly created production environment. The way we're doing that, the CF create service command, we tell it what is the service type, which is MariaDB, what is the plan, which is prod, and what is the service name, which is RockDB, as it appears in our manifest. You can see that this space and service was actually created in its own namespace. This is this long name here. And inside I have a master and a slave. And of course, I can decide that the plan for dev have only a master. It doesn't have a replica. Pretty easy as a DevOps persona to define those things. We can check if the service deployment has been completed. It's created successfully. Now we are ready to go back to our pipeline and hit production. 3, 2, 1. We can, of course, do this automatically if we want. So now we are pushing the app to production into our environment created on vSphere with Kubernetes, embedded Kubernetes on top, and then the Tanzu application service. The source code, the build code that we are pushing is the one we verified that works well with the green bar on both our testing and UAT environments. And we're going to see what the pipeline is actually doing here. It's binding into the environment that, first of all, it doesn't find the app, so it needs to create it, and it's binding into the database that we just created called RockDB. And this is the environment we're targeting. You can see that I have no idea which cloud is it on, if it's on Kubernetes or VMs, and where it's running, and that's the developer abstraction we actually want. And now we're binding into the RockDB database that we created from our Kubernetes service marketplace in the previous steps. The pipeline is actually going to do something pretty nice here. It's going to create a blue-green paradigm where it has an older version versus a newer version, and it's just switching the traffic. So we will have minimal or if no downtime, just the route switching when we actually move from blue to green. And here we can see a little bit of the plumbing of what's happening inside Cloud Foundry on Kubernetes, or the Tanzu application service on Kubernetes. This part is the cloud native build pack. Basically go and create the middleware around your source code, identify that this is a Java app, and adding the different layers, and using this as a way to curate. You can use this as a way to curate your consistent middleware, so there will be no different components and things that are not secure. The build service can actually rebuild if there is proactively if there is a security problem in one of the underlying components. And after that's built, the next thing you'll see is the service mesh point using Ezio and Proxy and Envoy, where all that plumbing is created for you behind the scene. And then the last step would be the Spring-specific steps where you're actually launching the app and connecting to the database. the MariaDB database that runs behind the scene. We'll give it a second to start the app. Now we are starting the app, 3 instances behind a load balancer that again we didn't have to configure. It's just running. And now everything is running. It's green. You can see that with the app is running and it's green.